morning all. So in the last class, we discussed about digital design flow. So where we have seen the classical digital design flow and the modern digital design flow. So the modern digital design flow, it refers the design flow, the digital system design flow uh, with the hardware description language. So today we will discuss about the concepts of the VHDL. So in the in the hardware description languages, so there are mainly two types of hardware description languages are available. There are many. There are two. Mainly, there are two types of the hardware description languages are available: VHDL, Verilog, HDL. So what is VHDL? So the VHDL is an acronym for VHSIC hardware description language. So again, here the VHSIC stands that the very high speed integrated circuit hardware description language. So the VHDL is an acronym for very high speed integrated circuit hardware description language. The second type of hardware description language is Verilog. So actually it is not an acronym. So it is just a trade name. So it is just a trade name, Verilog hardware description language. So the VHDL and Verilog HDL. So these two are the the current industry standards today, and they are widely using in the industry's applications, VHDL as well as Verilog. So these are the types of the hardware description language. So we shall discuss the VHDL, very high speed integrated hardware description language. As we know, what is a VHDL? Very high speed integrated circuit hardware description language. So here this VHDL language can be regarded as an integrated languages. It can be viewed, it can be see that it is an integrated of the different languages, we can say. So that's why here the VHDL can be regarded as a sequential language. So you can say that what is a VHDL? So instead of saying that it is a programming language, so you can say that the VHDL is a sequential language. VHDL is a concurrent language. VHDL is a netlist language. VHDL is timing specifications language. VHDL is a waveform generation language. So what is a VHDL? So VHDL can usually it is a programming language, but so it can be viewed as a sequential language, concurrent language, netlist language, timing specifications, and the waveform generation language. So which means that a VHDL can describe a system, or in the VHDL it can processing the sequential statements here. It executes the sequential statements. And the VHDL can also execute the concurrent statements. So sequential statements means, so the order of execution will be in a sequence. So there will be an order, accordingly the order. So the execution will be going on. Where in the concurrent, so you will have the random execution here. So concurrent, in the concurrent language, you can have the random statements execution. So here the VHDL can support for the sequential language, and it support for the concurrent statements. So which means It executes both the sequential statements and the concurrent statements. And the third one, netlist language. So the VHDL can be a netlist language. So how you can tell that it is a netlist language? Because the VHDL is a high level language. What do you mean that high level language? You are describing the digital system, or you are designing the digital system at higher level, which means that you are writing the statements, you are writing the statements to describe the behavior of the device. So therefore, so it will be like an English statements in the VHDL. The description will be in English statements. And now we wanted to translate, or we wanted to design the digital system. So for designing of the digital system, we require digital components, digital elements we require. So now this VHDL, it converts the high level documentation or the high level of the system description into gate level description here, into the gate level description. So that's why here it is a netlist language here. So what does it do here? It translates the VHDL code, which is in the English statements. So that is translated into the gate level circuit. So this netlist means that it just simply provides the gate level components and their interconnections. So that's why the VHDL can be viewed as the netlist language. It is viewed as a netlist language. It executes the sequential statements. It executes the concurrent statement. So that's why it is a sequential language, concurrent language, and the another one is netlist language, because it converts the VHDL code into gate level. And then the timing specifications here. So using this VHDL, you can model the delays of the system here. You can model the delays of the system, the propagation delay, inertial delays, etc. So here the VHDL can be model the device with the timing specifications. And the VHDL can also be a waveform generation language here. So here you can test the functionality of the designed digital system. You can describe the digital system by performing the simulation. So in the simulation, so it generates the waveforms. When you perform the simulation for a VHDL code, it will give you the results in the form of the waveform. So it generates the waveform here. So that's why a waveform generation language. So VHDL is a very high-speed integrated circuit hardware description language. It can be viewed, or it can be seen as a sequential language, a concurrent language, netlist language, timing specifications, and waveform generation language. All these together specifies a VHDL. Okay, and the next one. So in VHDL, a digital system can be designed at 3 different levels of abstraction. In our previous session, we have seen the levels of the HDL abstractions. Do you remember that? The levels of the HDL abstractions. So what are the levels of the HDL abstractions? System level, algorithmic level, okay, gate level, circuit level, material synthesis level, gate level, circuit level, material level. So there are 6 abstraction levels in the hardware description language. But coming to this VHDL language, a digital system can be modeled, a digital system can be designed at three different levels of abstraction here. So they can be designed at three different levels of abstraction. So what are they? So the three levels of the abstractions in the VHDL are behavior level. So a digital system can be modeled at behavior level. A digital system can be designed at at data flow level, and a digital system can be modeled at the structural level of modeling. So that's why these three are known as the modeling levels of the VHDL. What are the various modeling styles, or what are the different modelings in the VHDL? So for that, so these three are the modelings of the VHDL. Three different levels of modelings, three different styles of designing. So our entire VHDL, uh, the digital circuits are designed in these three levels only. At these three levels only we will design. So what are the various modeling styles in VHDL? The various modeling styles or different levels of abstraction in VHDL are the behavior level, data flow level, and the structural flow level. And there is another possibility that the combination of what here? The behavioral and the structural. There is another possibility of combination, that behavioral and the structural. That is the combined level of design. Okay. So for this slide, so what are the conclusion points here? What is a VHDL? The acronym for the VHDL is the Very High Speed Integrated Circuit Hardware Description Language. And the VHDL can be viewed as or it can be a sequential language, concurrent language, netlist language, timing specifications, and the waveform generation language. And the third point, what are the different styles, or what are the different modeling of the VHDL? So they are the behavioral level, data flow level, structural level. So remember these points, they are very important. And the next one. So now coming to this VHDL. So in the VHDL, if we want to design a digital system, so if we want to describe a digital system, so the hardware abstraction in the VHDL requires the mainly two things here. What are they? VHDL entity, VHDL architecture. VHDL entity, VHDL architecture. So now, so what for this VHDL entity and VHDL architecture? So now we wanted to design a digital system. So, and we are describing the digital system in terms of the VHDL code. By writing the VHDL code, you are describing the that circuit here. So now when we want to build a model, so we require two main things. One is entity, and the second one is architecture. So what is this entity here? Entity, it describes or it specifies about which circuit is to be designed. Suppose we want to design a full ladder circuit. So now what is the entity of that model? The entity of that model is full ladder circuit. So we want to design the full ladder circuit. So now what is the entity? The entity is full ladder. So which means that it describes about the external interface here. External interface. So what do you mean that external interface here? For example, we want to design a full ladder circuit here. We want to design a full ladder circuit. Actually, we don't know what is the exact circuit in full ladder. Say. So now, how we will define the full ladder here? So we will take a black box. We will take a black box, and for that we will define the inputs here. So for a full ladder, we want to have the three inputs. and for the output we want to have the two inputs. So therefore here this entity, it describes about the external interface here. I mean that the input and outputs here, because the input and output ports are very important in order to communicate with the external devices. So the entity always describes the external interface here. That is what in this here we have shown that with a block diagram, a black box. A black box is actually don't know what it is going to realize here. But once if you have given, or once if you have specified the number of inputs and outputs, then we can come to know that that logic function has 3 inputs and 2 outputs. So the entity always describes the external interface, which is about the input and output ports, right? Now the second important is architecture. So what does this architecture do? So here the architecture defines the internal function. So what we done here in the first one, we have taken an example that we have taken a black box, and for that we have defined the 3 inputs that let's say A, B, C. We don't know actually what the functionality of that block, but we take that A, B, C are the inputs, and we want to have the 2 outputs, sum and carry, say S and C. So now actually what is inside this block we don't know now. So now, so the functionality of this logic function, will be described by the architecture, So the entity and architecture are very important here. For designing of any digital system or digital circuit in VHDL, so we required, the first one is entity and the second one is architecture. Entity describes the inputs and outputs of that logic circuit, and the architecture describes the behavior of the circuit, how the circuit behaves, whether it is a full adder circuit, or it is a half adder circuit, or it may be a comparator, decoder, encoder. So how we can define that? So that is with the help of the architecture, here. So do you understand this? The VHDL have the 2 main parts here, entity and architecture, for describing the digital circuit in VHDL. We require these 2, entity and architecture. So the next one, is the VHDL conceptual model. So now in the previous slide we have seen that a VHDL model, model is nothing but design. A VHDL model is nothing but design. Which circuit we are going to design, that is model. So now in the previous slide we have seen that the VHDL model, it consists of the architecture and it consists of the entity. Entity is to define the interface of the input and output ports, and the architecture describes the functionality, the behavior of the circuit. So now if you see this, the VHDL allows the user to define the multiple architectures here, in a single entity. So an entity can have multiple architectures. It can have n number of architectures, but when you have the multiple architectures, we must need configuration. So we will see what is configuration. So here the VHDL allows the user to have in a single entity multiple architectures can be realized, and it also provides the configuration. So what is the significance of this configuration? So by by using this configuration management, so here a particular, so here you have a single entity with multiple architectures. So now which architecture has to relate to this entity here? Because in this in the simulation we can simulate all the architectures at single time, or a particular architecture can also be simulated here. So now, so this architecture always has to refer the entity here. It is always has to refer the entity here. So for that, the configuration will be used here. So when you have a multiple architectures, so then we have to configure them for the simulation purpose, and even for the later on for the logic synthesis too. Okay, so here for this slide, you can understand that a VHDL can have multiple architectures. You got it? So for designing of any digital system, we want to have, so the digital system will have an entity and a multiple architectures. It can have a single architecture or it can have the multiple architectures. If it is the case of multiple architectures, then we require the configurations. We require the configurations. So what is the simple use of the configuration is to binding the one architecture to the another architecture, to connect the one architecture to the another architecture. So that is what I am saying, the binding. So binding the one architecture to the another architecture. So the next point. So now the same point we can see here. So usually here a digital system will have the two important parts. I mean that a digital system in VHDL relies with the entity, with the entity, with the entity, and the second part is architecture, and the second part is architecture. So this is for one case. But now see, when you have a single entity with the, when you have a single entity with the multiple architectures, you say, so a single entity, let's say this is a entity 1, okay, and to this entity E1 there are three architectures are connected. So this architecture is corresponding to this entity 1 only, not for any other entity. So this is A1 architecture, say, and A2 architecture, and then A3 architecture. So these three architectures are related to the entity 1 only. So now you take another model. So now a model will consist of entity. A model is consists of entity, and it will have a single architecture or it can have the multiple architectures, right? So are you following? So a single. So now you take the second one. So here the second model. So this one is the second model, this plot. So it has a entity of name E2, and again this entity E2 has the two architectures here, A1 and A2. And you take another one. So now if you take the another one, so now the another model will have the separate entity. Say the entity is 3, and now this entity has the multiple architectures. Assume that multiple architectures. So now again A1 and A2. So now see, the entity 1 refers to the a model 1 is a digital system 1, and entity 2 is a model 2 digital system 2, entity 3 is a model 3 digital system 3. So now the first entity itself has the 3 architectures, second entity has 2, and the third entity has the 2 architectures. So now in this first entity, now let you assume that the architecture 2 is using a component here. In the architecture, we are using a NAND component. Say, NAND gate we are using in the architecture. Assume that. So, when you are using a NAND gate, therefore here the NAND gate will have a separate entity and the architecture, isn't it? Because the NAND gate is a component, it is treated as a digital device. So now the digital device will have the entity and architecture, right? So now, so you are using the AND gate in the architecture 2 of the entity 1. So now when you are executing this NAND gate in the architecture 2 of the entity 1, so now when this VHDL executing, so now it is referred to this entity E2. Why? Because we are assuming that this is a NAND gate device. And similarly, the A3 is another architecture. In this, we are using a component, say any of the component X. It is a digital circuit, say. So now this will be component. So now this component, it is refers to the entity 3. So what we can understand from this here, so a digital device or a digital model, it will have the entity and architecture. The architecture may be a multiple architecture, but in that architecture of a corresponding entity, so we can use the other devices entities. When you are using the other devices entity in your architecture, now the entity is becoming as a component. The entity is now become as a component. We no more call it as a entity. That is call it as a component. When if you are using the separate entity in your architecture part. Okay, so that is the multiple architecture concepts here. So an entity with the multiple architectures, and when you are using another entity in your architecture, the entity will be become as a component. Say NAND gate. Example చెప్తున్నాను ఇక్కడ NAND gate. ఎందుకంటే NAND gate అన్నది ఏంటి ఇక్కడ మనకి a separate digital device. ఈ సెపరేట్ డిజిటల్ డివైస్ ని మనం ఏం చేస్తున్నాము, సెపరేట్ గా మోడల్ చేసాము, బట్ దీన్ని మనం ఈ ఆర్కిటెక్చర్ లో యూజ్ చేస్తున్నాం. అందువల్ల ఇది ఏంటవుతుందంటే ఈ డివైస్ ఇక్కడికి వచ్చేటప్పటికి కాంపోనెంట్ అవుతుంది. దట్ విల్ బి యూజింగ్ యాజ్ ఏ కాంపోనెంట్, రైట్? అండ్ ది నెక్స్ట్ వన్, reserved words. So what is the significance of reserved words? You take any programming language, there are some keywords and there are some reserved words are available. So there are some reserved words are used in that language here. Similarly, our VHDL language, in our VHDL language also, we have a reserved words which are known as the keywords. So the VHDL defines many special character strings called the reserved words or the keywords. So you know the significance of the keywords. So once if it is defined as a keyword, you cannot use it as a user identifier. You cannot use it as a user defined variable. So there are many keywords are in the VHDL. So out of which, so here only some of the reserved words I have shown. So entity is a reserved word, port reserved word, is, in, out, and even if you see the R is also reserved word. So that's why while we are writing the a VHDL code, we cannot take the R as a user defined variable because it is a reserved word. It is already defined in the packages of the VHDL. And similarly, AND gate, you can't use AND straight away. So how we can use then? So that can be used with a R2, which means 2 input R gate, or you can give R underscore A. Okay, there are different reserved words are there. So some of have shown here. So the entity port is in, out, end, architecture, begin, when, else, not, or, and, NAND, not. These are all, there are many are there. So these are the some of the VHDL reserves. VHDL reserved words are the keywords. Okay, and then coming to the, so now our second unit, VHDL, mainly deal in this we will discuss all these points here, and in addition that we have the sub programs also. Here I have listed only few. The syntax rules, so we will see how the syntax rules are for the entity architecture or for the packaging or configurations. Time to time we are not discuss all these things at a time, so time to time we will discuss here syntax rules. And the very important one is the design units. The design units are also called the design constructs. So these are also called the design constructs. These are also called the design constructs here. There are 5 design units. And the identifiers. The identifiers are very, very important for any programming language here, because there are predefined rules are there. According to that only we have to build a program, or you have to write a program here. So there are VHDL identifiers. So we will discuss the VHDL identifiers. And then the other VHDL elements are the data objects here. So there are different types of the data objectives, and all are classified into only 4 in the VHDL. The 4 are the the signal, variable, and file. Okay, so these are the different objectives of the VHDL. So we will going to discuss the data objects and data types here. So there are different types of data are there. So here some of only an example here given, the enumerated, integer, arrays. But there are different real data, real type, and the time type, bit vector type. These are all different data types here. So in our forthcoming classes we will discuss these things, and also the also about the bindings and subprograms, because all more or less all these are covered under these topics only here in the design units itself, because this is the major topic here. So now what are the design what are the VHDL design units? So in the VHDL, we want to, if we want to design a digital system, we require the VHDL entity and VHDL architecture. We have already seen in our preceding in our previous slide, right? So now what are these VHDL design units here? So in order to design the digital system, or in order to build the digital circuit, in VHDL, we use the 5 design elements here, 5 design units. So the VHDL uses 5 design units. It uses the 5 design units for describing the digital circuit. For designing the digital circuit, it uses the 5 design elements or the design units. So what are they? Entity declaration. We have already seen that. So the major parts that we have seen in the previous slide is entity declaration architecture of the VHDL. But now, in addition to these two, there are other design units or the elements are there. All together are used to design the digital system in VHDL, or you can describe the logic circuit in the VHDL. So now what are the design units of the VHDL? The design units of the VHDL are The design units of the VHDL are entity declaration, architecture body. You know what is the entity declaration? What is the purpose of entity declaration? In order to define the inputs and output ports of the logic system. And architecture body. So what does the architecture body do here? It describes the behavior of the logic function, logic circuit. And then the third one is configuration. So what is the configuration? When you have multiple architectures in an entity, or when you have two different design models, and if any one of the any one of the entity of a digital system is being used in the other digital system model, then we need the configuration. సో ఇంకా సింపుల్ గా అర్థం చేసుకోవాలంటే కాన్ఫిగరేషన్ డిక్లరేషన్ అంటే ఏం చెప్తుంది? సో when you have a multiple architectures, so in order to combining of the multiple architectures, we can use the configurations. So there are bindings and subprograms are there to interconnect the one architecture to the other architecture, from one digital system model to the other digital system model. That is configuration. Okay. And then package declaration and package body. What are these package declarations and the package bodies here? Package declaration and package bodies here. So here in these packages, I mean these two are comes under a single concept of the packages, libraries and packages. A simple concept of the libraries and packages. So the libraries and packages will have the two parts here, that is the package declaration and package body. So don't get confused here. So the VHDL design units are, there are 5 design elements or 5 design units, and these design units are used to build the digital circuit in VHDL. Remember that. So they are the entity declaration, architecture body, configuration declaration, package declaration, and package body. Okay, so I hope you understand the first 3: entity, architecture, and configuration. So configuration దేనికి ఉపయోగపడుతుంది? మల్టిపుల్ ఆర్కిటెక్చర్స్ ని కంబైన్ చేయడానికి ఉపయోగపడుతుంది సింపుల్ గా. Okay, and package declaration and package bodies ఏం చేస్తాయి? So these two, package declaration and package body. So these allows the user to define that are not defined in the VHDL language. So the user can also define some packages here. So the user can also define their own packages or their own libraries here. So when the user has defined his own package body, when he defines his own packages, so in addition to the standard packages, so they will be all done using this package declaration here. So simply the package can be understand that it is a collection of commonly used data types and the subprograms. అంటే మనకి VHDL కోడ్లో మనం ఏం చేస్తాము? కోడ్ రాస్తాం. దేనికి? ఒక డిజిటల్ సిస్టమ్ డిజైన్ చేయడానికి, రైట్? సో when we are writing a VHDL code for describing the behavior of the circuit, so there are the packages here. In what way we can describe is, see, if you take an input signal, if you take the interfacing signals, so in the interfacing signals, the signal may be an input signal, or the signal may be an output signal, or sometimes the signal may be in and out here, right? ఒకసారి మనకి ఏంటంటే సిగ్నల్ డేటా లోపలికి తీసుకోవాలి, ఇంకోసారి డేటాని బయటికి పంపించాలి, ఇంకొకసారి ఏమవ్వాలి? సేమ్ సిగ్నల్ ని మనం ఇన్పుట్ కి అవుట్పుట్ కి కూడా వాడుకుంటాం. సో ఇవన్నీ ఏంటి? స్టాండర్డ్, all these are the standard predefined packages all. All these are the standard predefined packages, right? But there are some other packages so that the user can define. So such packages can be described, they can be described with the help of the package declaration and package body. So we will see later separately this one. So first we will mainly focus on these two here. Why these two here? Because for any VHDL code, we will have the entity and we will have the architecture. If you understand the entity and architecture, then you may be able to write an VHDL code, or you can at least try to attempt to write a VHDL code here. Once if you know this entity declaration and architecture body. Okay, so these are all the 5 design units. Remember, these are all very important. Short answers lo chala vadu karige questions iటువంటివన్నీ kuda ivanni simple. So now what are the VHDL design units? There are 5 design units: entity declaration, architecture body, configuration declaration, and the package declaration and the package body. So now we will first discuss the first two, entity declaration and architecture body, right? So now before we going to see the entity declaration and architecture body, so now these whatever we have the design units in the VHDL, whatever the design units we have in VHDL, they are mainly classified into 2 classes here. They are mainly classified into 2 classes. The first one is the primary design units and the second one is the secondary design units. Primary design units, secondary design units. From the name that you can understand, primary, they must have to be in the VHDL code. Secondary design, optional. If it is necessary, you can have. Okay. So primary design units and the secondary design units. So all the 5 design units are classified into 2 classes here: primary design units, secondary design units. So now what are the primary design units here? So these units exist independently in a design, because an entity, if you take, it is the independent of the VHDL design. Without the entity, there is no VHDL design. It is the independent. So the entity declaration and the configuration and the package declaration. So these 3 are the primary design units, because without input and outputs, you cannot go for the digital circuit design. Without knowing of the number of inputs and number of outputs, so how we can realize a circuit? We cannot. And then the configuration is important. Configuration. So when you are designing a digital system and you are using some other digital system entities and architectures, or some other digital systems entities you are using, some of the digital systems architectures you are using. And so in such cases, the configurations are very important, because we have to bind the architecture of that device to the current device. And the package declarations are very, very important, because without specifying the type of package, so how we can define the type of the signal here? ఇప్పుడు నువ్వు ఒక ఇన్పుట్ డిఫైన్ చేశారు, మీరు ఒక ఇన్పుట్ డిఫైన్ చేసినప్పుడు అది బిట్ టైపా, బిట్ వెక్టార్ టైపా? బిట్ వెక్టార్ అంటే ఏమవుతుంది? ఇప్పుడు మీరు A0 A1 అని 2 సిగ్నల్స్ తీసుకున్నారు అనుకోండి, ఇది ఏమవుతుంది? వెక్టార్ అవుతుంది. అదే మీరు ఒక సింగిల్ తీసుకున్నారు అనుకోండి, సింగిల్ సిగ్నల్, అప్పుడు ఇది ఏమవుతుంది? బిట్ అవుతుంది. ఇదేమవుతుంది? ఇక్కడ సెకండ్ ఆప్షన్ A0 A1 బిట్ వెక్టార్ అవుతుంది, రైట్? సో ద ప్యాకేజ్ డిక్లరేషన్స్ ఆర్ వెరీ ఇంపార్టెంట్. So these are the primary design units and the secondary design units. So what are the secondary design units? These units are used in addition to the primary units. So most of the time, as we said, that the entity and architectures are very necessary to build the VHDL code. But the entity comes under the primary design unit and the architecture comes under the secondary design unit. and the package body. So the secondary design units are the architecture and package body. What are the primary design units? Entity declaration, configuration declaration, package declaration. By the name itself, you can understand declaration. Declarations are very important. Without that, you cannot go into the circuit and you cannot describe the functionality of the circuit, right? So the second is secondary design units are architecture and package body. So right, today we will end for today we will end at this point, and tomorrow so we will continue the entity. So tomorrow we will continue with the entity and architecture of the VHDL. So do you understand the today's concepts here? Yes, I need a quick response, please. ఏమన్నా నేను ఎందుకు చెప్తున్నాను అంటే జనరల్గా ఏంటంటే కొంతమందికి ఈజీగా అర్థం చేసుకుంటారు, కొంతమంది ఏంటంటే అర్థం చేసుకోలేకపోవడానికి ఛాన్సెస్ ఉంటాయి. ఇది ఈ బేసిక్ ఇంట్రడక్షన్ కాబట్టి మీరు సాధ్యమైనంత వరకు కొంచెం ఫోకస్ చేసి ఆ మేజర్ ఇంపార్టెంట్ పాయింట్స్ని క్యాచ్ చేయగలిగితే లేటర్ ఆన్ ఏంటంటే చాలా ఈజీగా ఉంటుంది. ఎప్పుడు వన్స్ మీరు ఈ సింపుల్ కాన్సెప్ట్స్ని మీరు క్యాచ్ చేయగలిగితే కోడింగ్ అనేది రాస్తూ ఉంటే మనకు అలవాటు అవుతుంటుంది. బట్ ఇక్కడ ఏమవుతుందంటే ఇవి జస్ట్ సింపుల్ పాయింట్స్, ఇవి ఈ ఆలోచన ఉంటే మీరు ప్రోగ్రామ్ రాసేటప్పుడు మీకు హెల్ప్ అవుతుంది. ఓకే రైట్. సో we will stop for today and we will continue in the next class. So we will discuss in the next class entity architecture, and then we will see the types of data types, data objectives. Okay, so do you have any questions? You can ask, otherwise we shall end the meeting. So shall I end the meeting?
Yes.
Okay, thank you all.